Good evening, guys. I hope you are all well. So today's lecture, or sorry, not lecture, so today's collab session is based on Learning Unit 4. So I am just going to start this section going through an example of something that's in your textbook. So I've just projected this page. It is page 77, if I'm not mistaken, in your textbook, but I have projected it here just for your just for ease of reference. Sorry, 73. Excuse me. So this is the start of Learning Unit 4, which is a section called Grouped Data. And it's very similar in nature to a lot of the stuff that we covered in Learning Unit 3, which was, your general measures, such as your mean, your median, your mode, your quartiles, your range, standard deviation, and so on. So pretty much the same calculation that we'll be doing here, with the exception that we are looking at grouped data. Now, remember in Learning Unit 3, we looked at ungrouped data, which is where your data values were just listed out for you. They weren't in groups or categories or intervals of data. They were just randomly listed out for you, and this is why we called it ungrouped data. Now, here in Learning Unit 4, you're going to find that we look at grouped data, meaning that when we have our data values listed out for us, it's generally in group. So, for example, you'll have 1 up until 10, and then a frequency column, which has, let's suppose, the number 3. Then you'll have 11 till 20, 21 till 30, 31 till 40, and so on. And let's just say we have these numbers. This is what we refer to as group data, where you have an interval or group. And then this number is telling you how many values fall into that interval. So this is what we look at in terms of group data. And I just want to start off by looking at how do we draw up something like this? Because very commonly you have a question. You might find this in your assignment as well. I'm not too sure. I can't remember. But you'll have data values listed out for you. So like we have here, 20 values that are looking at the number of days or number of seminar training days that were attended by 20 financial advisors. So they've said to you 16 days were attended, 21, 20, 21, 13, 18, and so on. So they've listed out these 20 values for you. And very commonly you have examples like this where they list out the values and then you are required to take these random values and excuse me, you're required to take these random values and put them into a table format like they are at the top here. So let me clear the screen. So what you're going to do is, firstly, you have a table with 2 columns. One where you have the intervals. So here I'm going to say, you don't have to label this intervals, but I'm just labeling it so that you understand what we're doing. So you have this column labeled intervals, and then you have a column labeled frequency. The frequency column is basically telling you the number of occurrences or the number of times that you recall, you'll find a value that falls into this interval. So here, remember you have 20 values in total. Your sample size is 20. So the first thing you're going to do is look at what is the smallest number in this data set. So if you look through this data set, the smallest number is the number 13. So you'll start it off with 13. Then you need to look at the largest number or the maximum value in this data set. And again, if you look through it, you're going to find that the maximum value is 24. What happens now is that you need to ensure that when you draw up or create these intervals, the minimum and the maximum number must be included in this. So let's suppose, sorry, just want to clear this so you can see what I mean. So 13 was the minimum value, 24 was the maximum value. When you construct this table, you want it to be such that the minimum value and the maximum value fall into these categories, because that would allow for other numbers to fall into them as well. So for instance, 24 is your maximum, meaning that the last interval must be inclusive or equal to the number 24. The first interval must also include the number 13. So it's obviously generally up to you. Each person is going to have a different interval that they use. Nothing is incorrect provided that you have all of the numbers included in your interval. So remember, ours start 13 and it ends at 24. So let's, for instance, work with, let's say, in fours. So we start off with 12. So I'm starting off, since 13 is the minimum number, I'm starting off with the number before it, so that we know that the number 13 will be included in this category. So 12 up until 16, that's the first one. The next one would be, since this ends with 16, the next one will start with the next number, which is 17. So you're going to count 17, 18, 19, 20. Actually, 12, 13, 14, 15, 16. This is actually 5 values because it's inclusive of the number 12 and the number 16. So 17 would be 17, 18, 19, 20, 21. So up until 21, and then the next one will start with the number after that, which is 22 up until, so remember, if there was a difference of 5 between the first two values, there'd have to be a difference of 5 between all of the intervals. So 22, 20, 24, 25, 26. And why I'm including the number is because it's from 12 and inclusive of 12 up until 16, and inclusive of 17 up until and including 21, and then from 22 including 22 up until and including 26. So I just want to write this neatly for you again. So it was 12 up until 16, 17 up until 21, and 22 up until 26. And what you're going to find here is that the smallest number, which was 13, would fall into this first interval, and the largest number, which is 24, would fall into this last interval, which is what we're aiming for. We want to make sure that every value in this data set falls into one of these intervals. So again, generally most people will have different intervals here, but what happens is you'll find that the test or sorry, the exam or your assignment will give you a starting point. So they'd say to you, maybe go from 10 till 15 or less than 15, which technically means the number before 15, because they're not saying including 15. They're saying less than 15, which technically means 10 up until 14. Sorry, I see a question here. Can you guys hear me? Gary, Theona, are you able to hear me? You can. Okay, so it is Irene. Let me just type to her. Okay, so back to what I was saying. So you generally will be given a starting point. So they'd say to you go from 10 to less than 15, which technically means that since I said less than 15, it would have been the last number before that. So 10 till 14. So the next one would start with 16 and it would go up until, so 16, 17, 18, 19, 20. So up until less than 21, which technically means 16 up until 20. Okay, so they'd give you a starting point and they'd say to you, continue like this. So as you can see, since there's a difference of 5 with the first interval, the next one would also have a difference of 5, the next one will also have a difference of 5, and you'll continue like that until the point where, and how you know when to stop is where you find that the last value in the frequency, like here it's 26, the last value of the frequency will, of the interval will have covered the highest value in your data set. Like in this case, 26 is the last value that we have here in your intervals, and the highest value is 24, which means that we have taken care of all the data values. So here in the first interval, perfect, Irene. Sorry about that. Okay, so the first interval is 12 up until 16. So what you're going to do now is identify and count the number of values that fall between 12 and 16, including the number 12 and including the number 16. So you have 16, then you have 13, then you have 15. So that's 3 so far, and then you have 15 again. So we can strike them off. So 16, 13, 15, and 15. So your first frequency is 4. And remember, this frequency is telling you the number of occurrences. So basically saying to you 4 values fall between 12 and 16, inclusive of 12 and 16. And you have between 17 and 21. So including the number 17, including it up until the number 21. So you have 1, I'll strike it off. Then another, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 values then fall between the intervals of 17 and 21, including 17 and 21. And then between 22 and 26 is just the 24 and the 22. So 2 values. So this is your frequency and how you draw up a numeric frequency table when it comes to your grouped data. And just to ensure that your answer is correct, you need to sum up your frequency column. So 14 plus 4 plus 2 gives you a total of 20. When you sum this up, this total must equal to the original numbers given to you. So you were given 20 numbers in total. When you sum these values up, it must equal to the original number of values, just to ensure that your total and your frequency count was correct. And that is correct because they did say to us that they gave us the figures for 20 advisors. So we have 20, and this is how you draw up a numeric frequency table. Okay, so sorry, you asked where are we now in terms of the book. We were on page 73. Okay, so this is how you draw up the table, and then I'm going to go ahead and get started with the calculations involved in this learning unit. So as I said to you, it is pretty much the same in terms of sorry, I just want to change this document. Okay, so one other thing, sorry, before I start with the calculations, one other thing that you can be commonly asked when it comes to this frequency table is to calculate something called a cumulative frequency. And I think this is one of the questions in your assignment. A cumulative frequency is literal to the word where we sum up our frequencies. So for instance, for the first, let's suppose we added on a column here and we said cumulative frequencies. So cumulative frequency is adding up the first frequency to anything above it. There is nothing above it, so the cumulative frequency will be 4. Then, sorry, I can't erase this page because, clear the screen because it's going to erase all the information we have. So I'll just write over that arrow. Then the next one is taking the 4 that we had here, adding on the next frequency. So 4 plus 14 gives you 18 as your next cumulative frequency. Then the 18 plus the 2 gives you 20 as your cumulative frequency. Here, there's nothing beyond that. So your last one is 20. The last cumulative frequency you have must again also equal to the original number of values that you were given. You can also be asked to calculate something called a relative frequency, which is just another way of saying convert your values into percentages. So let's suppose, and I'll do it on the side, you were asked to calculate the relative frequency. How you'll do that is you take each frequency. So the first one is 4 over the total of 20, and you'll multiply it by 100 to convert it to a percentage. So 4 over the total of 20 times 100 gives you 20%. Then next one is 14 over the total of 20. So 14 over 20 multiplied by 100 gives you 70%. And then the last one is 2 over 20 multiplied by 100. So it's each individual frequency over the, so that's 10%, sorry. It's each individual frequency over the total multiplied by 100. So again, a very commonly asked question, and I'm pretty sure one that's in your assignment as well. Okay, so again, back to what I was saying, I'm going to go ahead and get started with the calculations that you'll come across in Learning Unit 4. I'm going to skip the first part of the learning unit, which you can read through and work through on your own. So remember I said to you that we'd be calculating the same values like the mean, median, the mode, your variance, your standard deviation, and so on. So we're going to work with all of these same calculations. The only difference is that when it comes to your grouped data, you're going to find that it's not as straightforward in terms of the calculations of each of these mean, median, mode, and so on. There's actual formulas involved, and you will find that these formulas are in your formula sheet. So you don't have to know the formulas, but obviously you do need to know what goes into them and what each of the symbols stand for. So first calculation we're looking at is your mean. And remember I said to you that this is what grouped data looks like, where you have intervals and then you have frequencies, which tell you the number of occurrences. Or it basically tells you, for instance, the number 6 says to you there are 6 values that fall between 20 and 30. In this case, it's kgs. Okay, so here this says to you that we're looking at the weight of 50 learners in a school. So they've given you the weight in kgs. Now, rightfully, these intervals should actually not be listed the way they are, because how your intervals work is that, so this says 10 to 20. What this means is it's inclusive of the number 10 and inclusive of the number 20. So technically, the next interval, if this is including 20, the next interval can't start off with 20 because then you've included 20 here and here. So the next interval actually needs to start with 21 up until 30, and then the next one can't start with 30 because then you'd have 30 here and here. And that means you would have counted the data value twice. If you had the number 30 itself, for example, you would have included it here and here. So your values can't overlap each other, your data value, your interval values, they can't overlap each other. So one common way that you can correct this mistake is the use of your brackets. A square bracket means including that number, so inclusive of 10, and a round bracket means excluding. So this means inclusive of the number, and that means excluding the value. So including 10 but excluding 20, which technically means 10 up until 19, because then the next one will start with 20. So this should actually read square bracket here, round bracket here for each one of these last values, because it's included only in one interval. It cannot be included in all of them. You'll find that they also often write it like this, which would say 10, like I showed you when we were going through that table, 10 till less than 20, which technically means that it's a number before 20. So 10 up until 19, and then the next one would say 21 up until less than 30, which technically means 21 up until 29, the number before that. Okay, so this is your table. I'm going to have to erase that. But as I said, it should have square brackets all over here. And these are round brackets, curly brackets. Okay, so then so we have all of your intervals here, which are also called bins for a weird reason, or it's called a class. And then you have your frequencies in this column. And the first calculation we're looking at is the mean. So the mean, when it comes to your group data, is calculated as a sum of fx over n. X is here, your midpoint, and I'll show you in a minute how to calculate it. F is the frequency that you have here. N is the sum of your frequencies. So when you sum up these frequencies, it gives you a total of 50. This is known as the value of m, your sample size, or the sum of your frequencies. Okay, so you have n, you know it's 50. You have your frequencies. The only value we don't have here is the value of x, which I'll show you how to calculate. And so the formula says, take each frequency, multiply it by its respective midpoint, and then sum them all up and divide it by n, which in this case is 50. Okay, so here, your midpoint, the value of x, and I'm just going to extend this table so we can calculate it. So I'll just do it here, and I'll label this column x. So how we calculate the midpoint is you take this first value of your interval, it's called the lower limit. You add on the second value of the interval, it's called upper limit, and you divide it by 2. So 10 plus 20 is 30 divided by 2, which is 15. Then you have 20 plus 30, so your lower limit is 20, your upper limit is 30. That's 50 divided by 2, which is 25. And then you have 30 plus 40 divided by 2, which is 35. Then 40 plus 50 divided by 2, 45, 55, and 65. Once you have this calculated, you now have in the formula, you have F, it's your frequencies, which is this column. You have your X values, which is your midpoints. And then you also have N, which is the sum of these, which is 50. So now you're going to, because it's a midpoint, Irene, so it's the middle point between your intervals. Okay, so you have your frequencies multiplied by its respective midpoint. So what we're doing here, and you'll also extend the table for this, and generally when you're answering this question, you do need to do it in table format. because their marks are located to the values that you are calculating in this table. So you would have added on a column for your midpoints, but I just included it in the table. You'll probably add it on like I have added on this one here. So you'll most likely have two columns added on at the end. Then you'll have, and please make sure that in your exam, you don't do this in your answer booklet. You need to actually redraw these columns in your answer booklet. You don't have to do all of them if you don't want to, but make sure you have the frequency, point, and this last one here. So fx is saying to you, take each frequency, multiply it by its respective midpoint. So basically 15 times 0 is 0. Then you have the next one is 6 multiplied by the 25, which is 150. Then you have the next one is 10 multiplied by the 35, that's 350. Then you have 45 or 18 multiplied by the 45, which is 810. And then you have 14 multiplied by the 55, which is 770. And then 65 times the 2, which is 130. Once you've done that, remember it says the sum of fx. So you'll sum that up. So the 0 plus the 150 plus 350 plus 810 plus 770 plus 130. Okay, so this gives you 2,210. Then it says take that total and divide it by n. So your mean is the total of 2,210 divided 50. And you will see on the next slide that the answer is 44.2 kgs. Sorry. Okay, so the same working out that I had done for you is all here also included here, where as you can see you have your frequencies, your bin mark. This is just a synonym for midpoint. And then you have each value multiplied by its midpoint, each frequency multiplied by its midpoint. So 0 times 15, 6 times 25, 10 times 35, and so on. You added them up, you divided it by 50, it gave you your mean of 44.2 kgs. Okay, so this is your mean. Then you have the next one, which is your median. So your median is calculated using this formula. The one in your formula sheet looks slightly different to this because instead of L1, they have the letter OME. I've just used the letter L1. It'll give you the exact same calculation. I've just used a different letter to symbolize what that value stands for. Instead of OME, I've put in L1 because L1 stands for the lower limit or the lower group boundary of the group. Okay, so you'll understand this as we go along. But please just bear in mind that it is the exact same calculation as the one you'll see in your formula sheet or your textbook. It'll give you the exact same answer. It's just that the symbols I've used to denote each value here is slightly different, just to help you to understand it better. So the formula for the median says L1 plus, then it says n over 2 minus, this says the sum of the frequencies. Sorry, just want to write that. It's the sum of the frequencies in the group before or less than, or the group before the group that you selected. And then it's over the frequency of the median group that you selected. And then you have on the outside here the letter C, which is known as the interval width or the size of the interval. Okay, so L1 plus, and then in brackets you have at the top in your numerator n over 2 minus the sum of the frequencies in the groups before the group you selected. And I say groups because there can be more than one group. And then it's over the frequency of the median group itself. And then on the outside, you have it multiplied by C, which is your interval or the size of your interval. So let's use this formula and identify what stands for what in it. So when it comes to your median, sorry, I want to go back to the table. When it comes to your median, there are 3 steps that we follow. Very similarly with your ungrouped data, the first step here is to determine the position of the median. The second step is to determine which interval or group we will find the median in. And the third step is to actually calculate the median using that formula we saw on the next page. The one that says L1 plus the N over 2 minus the sum of the frequencies, blah, blah, blah. Okay, so I'm not going to write out the whole formula because we'll look at it in a second. So when we're doing the first step, we're determining the position of the median. The formula we use to determine the position is N over 2. It's a given, it won't change. It is N over 2 to determine the position. So remember, N is also known as the sum of the frequencies over 2. This will tell you the position of the median. Once you know that, based on the position, you're going to determine which interval you'll find your median in, and then you'll calculate the median. So going back to the table, okay, so here, the first thing we're going to do is determine the position. N over 2. N is the sum of your frequencies, which you said was 50. So 50 over 2, which tells you that your position of your median is the 25th value in the data set. Once you know the position, you're going to look at your frequency column because your frequency column is telling you the number of occurrences or how many values fall into each interval. So you're looking for the 20th value. 0 is saying to you that so far there are 0 values, so it can't be that interval. Then we'll add on the next interval, and it's saying so far there's 0 plus 6. There's 6 values in total. So it can't be that because we're looking for the 25th value. So not the first 2 intervals. Then you're going to say 6 plus the 10, 16 values. Again, so far we haven't found our 25th value, so it can't be the next interval. Then when we say 16 plus the 18, that gives us 34 values now so far. Now this means that when we added on the next frequency, this is where we found our 25th value. So our interval that we've chosen is then, and this is our median interval, it's then 40 till 50. Okay, so this is our interval. So remember, once you've determined the position, you're going to look at the frequent column. Then you're going to, you identify now it's the interval 40 to 50. Remember the first value in the interval, the 40 is your lower limit. It's also called L1. And the 50 is called your upper limit, or L2. Okay, now the formula, which is the third step, says L1 plus, then you have N over 2 minus the sum of the frequencies in the groups before the group you selected over the frequency of the median group itself, and then multiplied by C on the outside. Okay, so the first portion is L1. L1 is your lower limit, and you selected the interval 40 to 50. So L1 is the first value, which is 40, plus n over 2 is the first portion of this bracket. N is 50 over 2, and then it's minus the sum of the frequencies in the group before the group you selected. So you selected the group 40 to 50. Basically, we're saying sum of the frequencies of the groups prior to this. And the groups prior to this had 0, 6, and 10 as their frequencies. So 0 plus 6 plus 10 gives you 16. Then in your denominator, it's saying the frequency of the median group. So the median group is the 40 to 50. Its frequency is 18. And then on the outside, you have the value of C, which is your interval width, which basically means the difference between 40 and 50. And here, remember, it's including the number 40, excluding number 50. So technically 40 till 49, including 40 and including 49. So I do suggest whenever it comes to your C value to physically count on your fingers a number that we're looking at, because it can get confusing. If it's including the number 40 and 49, it will be 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So your C value is then 10. If you were counting on your fingers, then you would have again included the number 40 up until and inclusive of the number 49. So your C value is 10. And so when you calculate this, so I am going to skip to the slide that has the value calculated. So as you can see, it was the 40 plus 50 over 2 minus the 16 over 18, and then your C value was 10. This gives you a median of 45 kgs. And so remember, when it comes to your median, first step is to determine the position. It's calculated as n over 2 always. Second step is to determine which interval would we find our median in by looking at the frequency column. And then the third step is to calculate the median, which is also known as Q2, using this formula. Okay, so that's your median. And then I'll just do your mode calculation and your skewness, and I'll stop for today. So your mode calculation works in a very similar way as well to your median, where, as you recall from learning unit 3, with your mode, it was just as simple as looking at the data set and identifying the number that occurred the most frequently. Now, with your grouped data, there's no way that we can identify a number that occurs frequently because we don't have individual numbers. We have groups of numbers. So what happens here is that we have a formula that we use. So you'll see this on the next page. Again, it is slightly different to the one that you will find in the formula sheet, but it is easier to calculate this way because you know what the values stand for, and you'll see that the one in the formula sheet and the textbook are quite complex. So obviously entirely up to you, but I like to teach it in this way so students are familiar with what the values stand for. Excuse me. So the formula says L1 as well. Sorry, you yeah, you can definitely email me, Irene, no problem at all. Okay, so the mode calculation says take the lower limit, L1, plus, so this first portion at the top in your numerator here within brackets, it says change 1. Remember, the symbol means the change or the difference. So the first difference is the difference between the group that you choose, its frequency, so the difference between the frequency of group chosen and the frequency of the group before it. Okay, so it's a difference between the frequency of the group that you selected and the group before it. And then the same is in the numerator, the first part of it, but then you add on the second difference, which is the difference between the group that we selected and the group after it. So you'll see in a minute when we do a calculation what we mean by that. And then you have the C value again, which is the same as it was in the previous calculation. It is the interval width or the size of the interval. So let's look at the data sets and I'll show you how to calculate the modal group. How to calculate the mode. Okay, so this is the information that will be given to you. The first thing that you do with the mode is identify the interval that we're using, the modal interval. How we do this is we look at the interval that has the highest frequency. And as you can see here, 18 is the highest frequency, and so the interval is 40 to 50. And so this becomes the interval we're working with. And then we use our formula. So our formula said L1 plus the first difference over the first difference plus the second difference multiplied by C. So L1 is, remember, the first value in your limit. L2 is the second. So L1 is 40 plus. Then you have within brackets, the first difference at the top is the freq of the group that you selected. So 18 minus the frequency of the group before it. So the group preceding it, which is 10. Not all of them, just the one group before it. Then in your denominator, the first part is exactly the same. So you can put in brackets and say 18 minus 10 plus the second difference is the frequency of the group we selected. So 18 minus the frequency in the group after it. So minus 14. And again, only the one group after it, not both of them. Okay, so 18 minus 14. And then your C value, which is your interval width, is again the same idea that we had where we said that it's a difference between the interval values. So 40 till 50, which means inclusive of 40, excluding 50. So technically 40 to 49, inclusive of 40 and 49. So again, you'll count on your fingers 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So that's 10 values. And so now you have all the values that go into the calculation. And I'm just going to skip to the slide with the answer. You have mode then of 46.67 kgs. Okay, so all of the working out that I had done with you is also here. And then the last thing for today is in terms of that mean, median, and mode, the symmetry of your data set. Now remember, this is pretty much identical, exactly the same compared to what we had done with your ungrouped data, where we said that they'd ask you in question 1 calculate the mean, question 2 to calculate the median, question 3 to calculate the mode, and then they'd say to you, based on those 3 calculations, comment on the skewness of the data set. Now remember, when the mean was equal to the median and equal to the mode, it was a symmetrical distribution. It's called a symmetrical distribution. When the mean is the greatest value and it's greater than the median and the mode, it's a positively skewed data set. And when the mode is the greatest value and it's bigger than the median and the mean, it's a negatively skewed data set. So like here in the questions we had been given, the mean was, from the previous slides, the mean was 44.2. Excuse me. The median was 45. We had calculated. You'll see it on the previous slides. And the mode was 46.67, if I'm not mistaken. So once we've calculated them, they're going to ask you to comment on the skewness. So as you can see here, the mean is the smallest value. It's smaller than the median and the mode. So basically the mode is the largest value, which means that, and you'll say that therefore the data set is negatively skewed. And you'll give the whole narration about the mode is greater than the median, which is greater than the mean. And you can even put in the values and say 46.67 is greater than the 45 is greater than the 40.2. And this is why it's negatively skewed. Okay, so I'll stop there for today. There is an example on the slide. Please, please, please try it out. And I will put up the solution for you. And we'll continue. I'll most likely do a recording of the rest of this. Do you guys have any questions? Okay, so if there aren't any questions, I'm going to go ahead and stop the session, end of the session, and then I will most likely do a recording and make it available to you. And if you do have any questions, please feel free to email me. Have a wonderful evening, guys. Stay safe. Cheers.